This is part 2 of section 6.2, and we're going to do some example problems using the law of sines. Okay, so if we're given the data from an angle ABC, we're going to use the law of sines if we are able to calculate the requested quantities, give exact answers if possible, otherwise give answers to the nearest tenth. What we're going to be looking for in order to be able to solve these triangles or find the missing piece is we're going to need an angle and a corresponding side. So here I have an angle C and a side C. That means I can use law of sines. If I had angle B and a side B, I can use law of sines. Now in this case, because we have two angles, we could easily find angle A and then use it if we had side A as well. But as we're not asked to solve the whole triangle, we don't have to worry about that on this problem. Okay, so since we are looking for a side, I'm going to use this version. We have B's and C's, so this is the part I'm going to be using. We're looking for B. So we start off with B over sine of angle B, which is 60 degrees, is equal to C, which is 4, over sine of 45 degrees. Now we just need to solve for B. Okay, so B is going to equal 4 times the sine of 60 degrees over sine of 45 degrees. And this will equal 4 times sine of 60 degrees is square root 3 over 2. And then I'm going to divide that by the sine of 45, which is square root 2 over 2. So this is the same thing as 2 times the square root of 3 times 2 over the square root of 3. Square root of 2, sorry. So that is 4 square roots of 3 over the square root of 2. We need to rationalize that. And we get 4 square roots of 6 over 2, which simplifies to 2 times the square root of 6. So the length of side B in this case will be 2 times the square root of 6. And since we were able to give an exact answer, that's what they're going to look for here. Okay. Now here, we're given the side A, which is 3, side B, which is 5, and angle B, which is 70 degrees, and we're asked to find angle A. So since I'm looking for an angle, I'm going to use the reciprocal version where we have sine of A over our length, 3, equal to sine of 70 degrees divided by 5. So this means sine of A is equal to 3 times sine of 70 degrees over 5. Okay? Now, you're going to go to your calculator and get an approximation for this because we don't have an exact answer for sine of 70 degrees. So you're going to find inverse sine of 3 sine of 70 degrees over 5. And your A value is going to equal that, or one of your A values is going to equal that, because we might have more than one. So you do this calculation and you get A is approximately equal to 34.3 degrees. And remember when we're solving with a sine, our other possibility, we subtract it from 180. And that will give you 145.7 degrees. Okay? So I got two potential solutions. I just don't know whether this one will actually work or not. So what you're going to do is I found out what this one would have to be. And then you add the other angle that you know. And if this is greater than 180, then this is not a possibility. And it is greater than 180. So that possibility is thrown out. This is the only solution. Our A value is 34.3 degrees. Notice that this is the side-side angle case, which I call the ambiguous case. We might have one solution, we might have two solutions, we might have no solution. Okay, so let's look at this one where C is 40, A is 70, and the angle C is 30 degrees. And we're looking for an angle again. This is another side-side angle. So again, we might have one solution, two solutions, or none at all. I know I have both values for C. So sine of A over 70 is equal to sine of 30 degrees over 40. So sine of A is equal to 70 times sine of 30 degrees over 40. And then your A value, at least one of your A values, or one of your potential A values, would equal inverse sine of 70 times sine of 30 degrees over 40. And you get approximately 61.0 degrees, rounded to the nearest tenth. Okay, so this makes sense. I have at least one solution, but I need to check to see if that second solution will actually work. So I do 180 minus 61.0, and you get 119.0. Now add that second angle to it, the one we know, and see if it's greater than 180. And that's less than 180. So that means this is also a good solution. We have two potential solutions here. Okay. Now, if B is 5, C is 8, and angle B is 135 degrees, find angle C. So sine of C over 8 is equal to sine of 135 over 5. So sine of C is 8 times sine of 135 divided by 5. Okay, so C will equal sine inverse of 8 sine 135 divided by 5. Okay, if you plug this into your calculator, you're going to get an error. Okay, and the reason we get an error is that because this is greater than 1. And we can't have a sine value greater than 1, so we can't take the inverse sine of a number greater than 1. There's no such triangle here. Okay? So here we have a side-side angle where we had one solution. Here we had side-side angle with two solutions. And here we had side-side angle with no solutions.